Hi, welcome to this video. Today we're going to be discussing the difference between electric potential and electric potential energy. Again, a very important concept to differentiate and get clarity over. I'm Atray. I am the teacher of physics and chemistry at Cosmic Essence Education, and if you're ready, get your notebooks out and let's get started. Now, a lot of students have this difficulty in understanding the difference between electric potential and electric potential energy. They get confused in the names and the language that we use and the definitions and the symbols. So this video I want to clarify all of that. Let's first get into electric potential energy. Remember, we're talking about potential energy at this point. Now, potential energy, electric potential energy, to be perfectly clear, is defined as the energy that is stored in a charge. Again, remember and understand the words very clearly. The energy that is stored in a charge when it is brought on from infinity to a particular point nearer to a source charge. Now, what is a source charge? Source charge is a charge or a system of charges which is creating an electric field around it, right? Because of this electric field, the outside charge has to push in, right? It has to push in to get to its point. Why? Because these two charges are of the same charge. That means both are positive or both are negative. At least we are assuming that in this moment. And when they are like that, they are repelling each other. That is a fundamental property of the charges. So when they are repelling each other, this creates a tension. This charge which wants to come in cannot come in without external help, and so I have to, or anyone else has to pick up this charge and pull it slowly into the orbit that we want it to, or into the position that we want it to. And in this whole process, the work that I am doing on the charge gets added on, gets attached and gets stored in that charge as it reaches the position. Okay, let's look at it visually. Suppose I have a charge Q like this. Obviously, it is creating an electric field in a spherical manner. I'm not making the entire electric field, but it is creating an electric field in a spherical manner all around it. I want a test charge, say Q, and I want this test charge here at a distance of r. I want this test charge here at this position at a distance of r from my capital Q. Now this, right now, my test charge is at infinity. Okay, so I have to pull it slowly to this point, and as I am pulling it from this point, I am storing that energy. The work that I am doing, I am storing all of that energy into this charge Q, right? Once you've understood this fundamental concept of how we are defining potential energy, then we can understand the difference as well. So potential energy, which is denoted by U, and this U is of this point P. So U is potential energy of point P, but potential energy always only is relevant as a difference, because we are only talking about that difference. That means that the difference between the final position P and the initial position of infinity. So I will write the potential energy difference of this. So potential at P, potential energy at P minus potential energy at infinity, which will be equal to the work done by me on the charge. Okay, which is equals to, how much is that equal to? It is equals to the Q into E. Why? The charge into, sorry, not E, this will be just, it will be equals to Q into Q upon 4 pi epsilon naught r. Okay, this we've already discussed in the potential energy video, so I want you to go back and watch that video if you don't understand how I'm writing it. I'm not going to the detail of the formula at the moment. So this is potential energy. So potential energy, we are storing that energy in this point. Now electric potential is equally easy. Electric potential. Okay, this is the definition. This was the definition of potential energy. Electric potential is simply, instead of Q, we are talking about a unit charge. Now unit can be per coulomb, per microcoulomb, per nanocoulomb, it does not matter, but it should be a unit charge, right? So we are assuming that for a unit charge, the amount of work that I have to do to pull an unit charge from infinity to this point P, all of that work that I'm going to be doing, it gets stored as electric potential. Again, just like potential energy, electric potential also only is relevant in terms of a difference. So Vp, which is potential at P, minus V infinity will be equals to the work done on unit charge. Extremely important, this difference of unit charge and potential energy, and this comes out as Q upon 4 pi epsilon naught into R. R is the final distance that we want. Okay, now as you can see from both the two formulas as well as the concept, the only different thing between these two concepts of electric potential and electric potential energy is the multiplication by Q. That means if rather than I was pulling in a charge of Q or a charge of 20 coulombs, then I will then call that electric potential energy rather than electric potential. And that is it. That is the only difference between electric potential and electric potential energy. The difference is just about what is the quantity of charge that we are bringing, okay, and what is the factor that we are multiplying it with. So in terms of formula, I can simply write this as UP minus U infinity upon Q. And that's it. This is the simplest example and difference that you will ever get. Okay, the difference is simply that electric potential only deals with the unit charge, and so we have named it as a separate thing called electric potential. But when we are dealing with more than unit charge, that means 20, 50, 100 coulombs or anything for that matter, then we are talking about the entire energy stored in that charge, and so we have named it electric potential energy. It's just the different names. The concepts are the same. And they are essentially the same thing, but just for a unit charge, that is a single charge, we have named it electric potential, and for multiple charges or more than one charge, we are talking about calling it electric potential energy. Okay, so that's it for this video. I hope you like this video and gain some massive clarity about electric potential and electric potential energy. If you did, please do like, subscribe, and comment on this channel. Do tell me what your doubts are, what your suggestions for the next videos are, so that I can make them as soon as possible. And do put in your comments of critiques or how we can improve as well. Share it with your friends and family so that you can think better with such clarity, because that's what the goal of education is, and that's what we at Cosmic Essence keep trying to do.